writing a game without using object-oriented programming?
Just doing the Overwatch and just
It's theoretically possible. I bet you it would take 10 times as long, easily, to do it that way. And the reason is that you need to manage your chaos when you're making a game. And this stuff here is all about managing the complexity of your game. How many of you guys worked on Pong? I know, Michael, you had some issues. Everyone had issues with it, where everything was kind of in one big function. There was a lot of duplicated code everywhere. There were a lot of things that were hard to manage just because of how much stuff was in one place. And no one wants to work like that. I don't even want to work like that. And I try my hardest to work around that. And the way that you work around that is by using these data structures that you are given. And the reason is that it's kind of like imagine that where you were reading a book where there was no chapters, there was no headings or anything like that, and everything in the book was literally just monospaced, no paragraphs, wall of text for the entire book. So like 10,000 pages of that, right?
Like every
and trying to
history
understand, what's that?
Like every history book?
Yeah, kind of like that, with no pictures, no titles, no page numbers, and just a straight wall of text. No organization whatsoever. Even though the content is exactly the same, if you just, put white space and some indentation and some headers, it can make a huge difference in how you can read and process that data, right? Same exact idea for programming, right? You can make a program without using this stuff, but this lets you basically make it in a way that lets you focus on what's really important at that time. Like, you don't have to worry about you don't have to read everything. You can focus yourself on the things that are actually really important. So to that effect, classes and data structures will let you basically take the pieces that are important, remove them from the rest of the project, like kind of put them in a box and put them in a separate location so that if you need to worry about it, you can look at them later so that you don't have to always be thinking about like, oh, well, like in this case, a product has a weight and a price. If I had an array of products, I wouldn't need to have an array of weights and an array of prices. I just know that I have an array of products themselves. Every product also, has a weight and a price associated with it. So it kind of also comes down to how you think about a problem. So if we were to talk about, let's talk about tracking stats in Overwatch for players, right? So this is talking about tracking like kills and deaths and games won and games lost and like, what heroes you play and stuff. Let's say that we're trying to make a stat tracking system. So, the guy that wrote this sits next to me, and so he's very good at this kind of stuff. But let's just go through the thought exercise of it. And there's kind of two ways that you can go about implementing this. Like if you were given this task on the Overwatch team and you're a programmer and you were asked to implement a stat tracking system, there's kind of two primary ways you can go about doing it. So,
building an array.
What's that?
Building an array.
So it's kind of more high level than that. I want to talk about, there's a way you can do it what's called procedurally, which is to think about how you would actually write the code. Like as you go, you talk about, well, I want to write a function that retrieve that's every time that you get a kill, that this function gets called and will set a value for your kills variable. I'll add, every time you kill a guy, I'm going to add 1 to that kills variable, which means I need to write a function somewhere for that. But I might need another function for tracking how many times you've won, and maybe another one for tracking like how many times you've lost, maybe another one for how many times you died. Maybe I need like you say, like an array of integers to track how many kills I have. Procedurally thinking about a program like this means that you're thinking about you experiencing like this in the game and trying to write code around it. It's kind of a weird thought. It means that you're thinking about how the game plays and trying to write the code around what you imagine the game would be doing. Which procedurally means that as you go, you're kind of like figuring it out as you go. And this is kind of actually the way you guys have all been writing your programs so far. Like I give you like a lab exercise or something like that, and you kind of start writing the code for it, and you start thinking about like what you need to do as you're doing it. And I want to take a step back because I want to introduce a different way to think about solving these problems, which is to think about things from an object-oriented programming point of view. And so this means that instead of just thinking about the problem from like the aspect of, hey, I need to write some code, like, oh, I need to track kills, so that means I should probably write a function. That means that whoever gets a kill needs to call this function so that it can track it. Instead, take a step back and think about the data that you want to represent. Think about it from a data point of view. instead of thinking about the code that you need to write that runs this logic, think about what kinds of things you need to represent in order to store this data. So in the case of stat tracking, let's take a step back, and instead of saying, how do I write these functions, instead let's ask the question, what things do I need to track? What are the stats that I need, and how are they stored? We did this a couple times in the past with things like Pokemon, where we had like a Pokemon object, and we asked, what describes a Pokemon, right? A Pokemon has HP, a Pokemon has attack, defense. I want you to start asking that question more. Like every time you approach a problem, I want you to ask, what describes something like a player and his statistics, right? And in fact, if we go down this road a little bit more, let's say we're talking about player stats. What describes a statistic in Overwatch? What are the things that describe a statistic? It has one number, which is the current value for your stats, so literally the kills that you have. What are some other things that describe a statistic? Because there's a lot more than that.
Accuracy?
Well, let's just talk about kills. One stat, which is kills. What kinds of things do you care about for a stat for kills? You care about your current kills,
Assist
right?
kill.
Not assist kill, that's a different stat. More like, what about your highest kills in a game that you've had? Yeah, like your highest kills. What about your average kills per game? What about your average kills total across all heroes? What about your average kills on a specific hero? What about your average kills on a specific map, right? These things, there's a lot more to a statistic than just a single number. And that's the kind of thing that belongs in a structure, right? So a structure for a stat will have an integer that could be, this is the current value. I have 10,000 kills. It would also have maybe some other ones, which is, hey, this is my average kills per map, right? So there'd be another number in there would be average, right? Maybe there's another number in there which is my career best in the map, right? So thinking about things from the aspect of a data structure means that you're thinking about things outside of like, oh, how do I write these functions? Instead, the first thing that you do is you describe the data that surrounds it. Once you have something like a statistic, now we can start talking about a player. What kinds of things describe a player in the realm of a statistic? Like a player has a collection of different statistics, right? A player has kills, a player has deaths, a player has wins and losses. And each of those things is a statistic, which has a current, a best, an average. So you can describe a player in terms of their statistics too. So they would have an array of all of these statistics that are currently being tracked for them, right? You could also do it per hero too. So like, oh, this player has a collection of heroes, and each hero has a collection of stats associated with it. I want to talk because this is a weird way to think about problems, and it takes practice to get to this point where you can start thinking about things from the point of view of what kind of data represents it. And the only way that you're going to really get better at it is by us doing work with it. So it's going to feel really weird at first because it's not going to really make any sense. It's not going to really make sense as to where variables go, like which variables go where, and like how you chunk apart those pieces. But we can do it on a simpler scale. Yeah.
I was wondering, could you take a class and put a structure in that class?
Yep, you can. You can make a class with more classes in it too. Like player would be a class, statistics would be a class. A player would have an array of statistics inside of it. And maybe statistics themselves have a class within them, which is maybe like, oh, I don't know, like a date, like a time and date. A date is a class that has a month, a day, and a year, right? Maybe a stat has a date that says when your best value for that stat was. Like, oh, you got top kills on February 13th, 2016, right? And that would be another variable inside the structure, right? So if I were to give you guys an example, so if I were to write that class, or just I'm not even going to use class, I'm just going to use structures here. If I had a structure for a stat, right, as I mentioned, it would have something like, we'll just do floats. Current, best, average, right? And there might be another structure, which is called a date, which has what? A day, a month, and a year. And stat would have within it a date, which is when you got your best. Okay? it would also have a player, which would have maybe, I don't know, 21 of these. So this relationship here is a very kind of straightforward relationship, but it explains a little bit about, first of all, what is a player made up of? He's made up of 21 of these stats. And a stat is made up of 4 variables, 3 of which are just simple floats, right? The 4th of which is another structure which has 3 integers inside of it, okay? How would I represent this without using structures? Can you guys talk about a little bit about how you imagine I'd represent this? Let's just say I want to have a player. Hey, Michael, you and I are going to be both players in here, right? How do I declare me and Michael, okay? There's player Keith, player Michael. Done, right? I have these 2 guys. Keith has my stats at like 0. He has a current, I don't know, whatever, 20. Maybe stats also have a name. I think they should have a name. But how would I do the same thing without using any structures? Without using any structures at all? How would I represent all of this information here for all 21 stats?
You'd have to put all those individual variables underneath each player.
I'd have to have a 21, yeah, I'd have to have a Keith kills stats, which would be, this is Keith kills stats current. This would be a float. This would be an array of 21. I would need one of these. So this would be best, average, main. Okay. I'd also need to have a date. Oh, I don't have a date. So I would have to have an int Keith kill stats date day month year. I'm basically taking all of this stuff and putting an array for each of them, right? So I think, yeah, that's that. And then Michael would have the same thing. Okay. If I wanted more than this, I would have to have more sets in this.
What was that shortcut?
So you don't need to worry about this because you're not going to be doing that. I'll tell you. I'll tell you later.
That's what we need.
So, but there's more to this too. Like this is crazy, right? Like this is a lot of arrays. But this gets even worse if I put an array inside of a stat, which I can totally do. Like maybe I just have like. Let's have an array of 3. Let's just do top 10 best. I'm going to have top 10 best stats. So I'm going to remember all my top 10. So I know like, oh, my best kills is 10, but my one below that is 9 and then 8 and then 7. How do I represent this down here? So here's what you got to do. You gotta multiply that by 10, so I need 210 of these. Okay. Because for every one of my stats, I have 10 best scores, right? I have 21 stats, and within each stat, I have 10 of these. So if I were to represent that with a single variable, I would need to have 210 of these in order to represent that properly. Right? At a certain point, this gets really, really bad, because if I want to have all my players be tracked, if I want to have everyone in this classroom be tracked, I can't just write them all like this. I have to actually have a separate one for every single person in this class, right? If I want to have every single person in this class represented using data structures, it's actually pretty easy. We have, what, 14 people? Done. That's everything I just did. Everything's represented in there. I have 10 stats. I have 21 stats per player. I have 10 top 10 stats. I have 14 players, right? By breaking apart the data in a way like this, I can simplify how I interact with this thing into like a very, very simple way to use it. That variable player is a very complex kind of variable. It has a lot of information inside of it. The best part is I can also add things to this variable without changing it. I can add a name to the player, because players have names. I can even make another data structure that makes this even simpler. Boom. So I don't even need to have an array of players. I just have a class here. If I want to get a player, I can get, I don't know, everyone, maybe this is Michael. Okay? And the best part is that I can say, hey, I can create a pointer. Now I have Michael as a player. And I can adjust stats for Michael however I want to. Michael is the second person, or he's technically the third person in the class, and he has all these stats inside. This is why data structures are important, though. And we're going to get into, I want you guys to practice more. I took us a little bit of a detour to talk about this because I think it's important. But does that make sense as to how this can turn into something powerful? This kind of thing, where breaking up things into breaking variables apart into data structures, is how you think about things from an object-oriented point of view. And when we make asteroids, we're going to do the same exact thing. Instead of players and stats, though, in asteroids, what kinds of things do you have in asteroids? Asteroids. What does an asteroid have that describes it?
It breaks apart.
No. What are the properties that describe it? What'd you say? It has rotation, right? So it has how fast it's spinning, how fast it's moving, where it is in the world. Size is a perfect example. How much HP it has, if it has HP. What about
collision, where like it goes from that one from top to bottom? So
that is not like a property of an asteroid. That is how an asteroid is moving. So there's a difference there because we're just talking about what describes an asteroid. Just talking about, like, think about an asteroid in a game of asteroids, and think about like what describes it, like HP, like how fast it moves and where it is. How it moves from one place to another, like from the top of the screen to the bottom, is actually how the game works. The game itself has properties inside of it, and one of the properties is that when you go to the edge of the screen, it goes from one side to the other. A player is another example. A player is actually pretty similar to an asteroid. What kinds of things describe a player? Has a position, right? How fast it moves, what the rotation is, whether he's shooting or not right now. Yeah. Bullets are also another object. Bullets are another example of a data structure you can create. Bullets have position, it has velocity. Those also have how much damage they do, right? How long they've been alive for, probably, because you don't want bullets to last forever. What about like a UFO in asteroids? You guys know there's UFOs in asteroids, the game. There's like a little AI that appears sometimes and shoots at you. What's that? Yeah, it has HP and a position and how fast it's moving and the rotation as well. A lot of these things can be described in terms that are data. Let's take it a little step further and talk about Pokemon, right? Pokemon can also be described. You can break apart the game of Pokemon into its piecemeal parts. Pokemon is comprised of Pokemon, right? Pokemon have HP, stats. They also have moves. Every move is an example of a data structure, is an example of a class or a structure. A move has how many uses it has left. It also has how much damage it does, how accurate it is. That describes what a move is, right? Even things like gyms have data structures defined in them, right? Like where they are, what city they are in, right? What badge they give when you beat them, okay? All right, questions on that stuff? Does it kind of starting to make sense a little bit, hopefully?
Yeah, I'm starting thinking like in structures.
Yeah, like how do you
do a whole gym as a structure, gym class, and then have each one have its own legitimate badge.
Yeah, what you want to break apart an object to as small as pieces that you possibly can. Okay, and having a structure with one variable in it is too small. Like you don't want to really do that. If you have something with just one variable in it, that's typically not worth it. But if you can get away with like 2 or more, like that's really where you want to be. You want to try to avoid having huge structures that have 20 variables in it, because that's defeating the purpose of it. Like if I took Pokemon and I just made one data structure which represented the entire Pokemon game, it's not any better than having it all doing it like what I did here as an example. What you want to do is make logical separations. Like you think about a car is another example, a perfect example of how they're able to take something to break it apart into smaller pieces. Someone designed a steering wheel. You could take off the steering wheel, and the steering wheel itself has a piece. That's a perfect example of something you can break apart into a data structure. An engine can actually be a data structure too, although an engine has a lot of little pieces inside of it too. All right, so let's talk about the actual parts of object-oriented programming and the syntax and how you're going to use it. So I want you guys to learn. So this is an example. An object, classes are an expanded concept of data structures. Classes and structures are functionally identical. They look the same. So even though it says structure here, we're going to use this as an example. This is a reminder of what a structure was. A structure corresponds to a keyword. So struct is always required when you're defining a structure. And product is the name of the variable type. This is the new variable type you're going to create. So notice here, these are variables, apple and banana and melon. These are names of the variables, and this is the type of it. And within the structure, you have curly braces to define where the variables begin and end, and a semicolon at the end. If you forget this, you will have lots of problems. You will have hundreds of errors in your program because of one missing semicolon. You'll see this, and it's going to be really confusing, and then you're going to see an error that says, hey, did you forget a semicolon somewhere? Every single class or structure needs to have this at the end. That is it's kind of a weird thing because you typically don't put that at the end of a curly brace, but remember, you need to have that, okay? A lot of you guys are going to forget it, so. Okay. So this is what the class declaration looks like. So first of all, I just want to talk about the word object. So an object is an instantiation of a class. So in the case here, if I go back a slide, if this said class here, these would be the class type. These are objects, right? These are basically apple, banana, melon. These are types. These are instantiations. These are instances of a product. Just like Pikachu is an object. A Pikachu is an instance of a Pokemon, right? Bulbasaur is an instance of a Pokemon. So this is the syntax for how you define classes. The first thing is that you always have to have the keyword class in front of it. Okay? It's just like struct. You can use struct here instead of class, or again, pretty much functionally identical with one minor difference. Then you create the name of what you want your class to be named as. So this can be Pokemon, this can be stat, this can be player or classroom, whatever you want your new variable to be. And then you get into these. So inside of a class. First of all, I want you guys to focus on the members. So ignoring the access specifiers for now, just these two, just ignore these. Member 1 and member 2, these are basically placeholders for variables that define what your class is. Member 1 and member 2 in the case of the product on the last slide. Member 1 is, this is a member, weight. Okay. Member 2 is price. These are variables. Going back to my variable, this is a member called stats. It's an array of stats. This guy has 6 member variables inside of it. Okay? This guy has 3 members inside of it. You're going to have every number of members that you want. There's no limit to those. So when talking about this, when I say member here, that just means variable. But members can also be functions too. So a class and a structure is both what variables define it as well as what functions are associated with it. So when we say, hey, describe something in terms of its data, I also want you to think about in terms of what it can do. So going back to asteroids, and we talk about an asteroid has a position, a rotation, and a speed. What's something that an asteroid does when you shoot it? It breaks. So that would be another member of the asteroid class. It would be like break. Okay? That would be a function instead of a property, though. That's something that the asteroid does. Okay? So there's 2 very important distinctions there. One is a class is comprised of what things describe it, so the data variables. but it's also the functions that describe what it can do. And those both are important. You don't always have both. Sometimes you actually only have data members, just like in the example here for product. You don't always have data members. Sometimes you'll have an object, a class, which only has functions in it. It's kind of more rare, but those kinds of things typically are used for utility functions. For instance, we have some classes for like utilities, things that are we call them, a lot of times we'll call them singletons, or we'll call them utilities, where you want this, you're writing a bunch of code and you want to put this function somewhere. You don't typically, when you're writing a function that's very useful across the board for everything, you don't just put it wherever. You actually typically either put it in a class or you put it in some other scoped object. You can put it inside a structure. But I just want you guys to realize that you don't need to have both variables and functions. Typically you have both. Typically you'll have both what describes an object and how you use it though. Okay? So those are what members are. Members are either a variable like int price or int current or float damage. These are what members are. But members can also be functions. And if you guys remember, functions are just a way to wrap up code so you can call it and have it run some code yourself. These access specifiers though, they're a very important part of C++. And to be fair, you could go your entire life writing programs and making games and just use one access specifier for every single class, which is public. However, I want to talk a little bit about why these things are important. So there's basically 3 of these access modifiers. And what they do is they will give you a compiler error if you try to use one of these members in an inappropriate way. It allows you to say, hey, if someone tries to use a member that I've written in a way that I don't want them to, throw a compiler error, because I don't want them to use it in that way. It's kind of a weird thing to think about, right? Like, why would you want to, 1, add compiler errors, and 2, like, even if you did this, the person that would be using it, like if Michael and I, or if Justin and I were working on the same project, even if we were both working on the same project, I have the code. Like if Justin's like, hey, I don't want you to use this thing. I want to throw a compiler error if that happens. I could just be like, well, screw you. I'm just going to delete it and just make it myself, right? There's kind of a code of conduct here that you have to follow. So it's kind of like you ever play a game and you have the option to use cheats to beat the game, like you use hacks and stuff? You have to avoid that impulse when you're working on a project. You have to avoid the impulse of just doing whatever's easiest. It's kind of like the rules, everyone walks on the right side of the hallway. Use your blinkers when you're turning in the car. Don't kill people. Don't shoot people. Just don't be a dick. But the key is that you write these things here, these access specifiers, and there's 3 of them. Okay. And you write them so that you kind of give a hint to the person looking at your code. This is purely for the people working with your class, to tell them how you want them to work with this thing that you wrote. And it's a lot like someone selling a phone, like an iPhone or something. Like people at Apple really want you to use the iPhone in a very specific way. They don't want you opening that thing up. They don't want you modding it. They don't want you removing the battery and replacing it. They really don't want you to do those things. So they make it very hard. Yeah, you can do it. It's hard, and typically it might even break your phone. That's the same idea, is that you kind of want to give someone who's using your class some help in understanding what the right way to use that thing is. A lot of times this is important because when you're writing the class, you might write things that only you feel like you should be the one kind of writing. Like you don't want anyone else to know how the internals of it work. Like let's say you're writing a class for Pokemon and you have a bunch of work, a bunch of formulas in there to calculate how much damage you should do when you deal an attack, right? But you don't really want other people to be writing their own formulas. You just want them to call a function that does it all for them. But a lot of times you want to make the internals of that kind of like, hey, if you're using my class, you can read the code for it, but you don't need to change it, or you don't need to be modifying it. And I'm going to tell you how to do that. So private is how you basically prevent this. So private, when you put the word private in with a colon, so replace access specifier with the word private, anything below that colon, anything below that private modifier is only accessible from this class and other members of the same class. So, which means that if I have a member here and there's a word private above it, that member can only be used within writing functions for this class or another class which has another class which is considered a friend, which we'll get to. There's a way you can say, like, well, this I only want this class to use, and this other guy, he's my friend, he's allowed to access my member too. Protected is a little less strict than private. It just means, hey, this class can access it, my friends can access it, and what's called derived classes can also access it. And we're going to get into derived classes more next week, because we're going to talk about how you can take a class and you can make more types of that class with just slight variations on it. All right. Then finally, public members. Public just means everyone can access it. Everyone can do whatever they want with it. I don't care. You can access it from anywhere. You can use that member variable. You can change that member variable. It doesn't matter to me. Or you can call a function that's a member. Okay. So a few things. By default, if you don't put one of these access modifiers on a class, everything is declared private. Okay? By default, everything is declared private. Structures, by default, everything is declared public. Just keep that in mind. That's the only difference between a structure and a class. So someone was asking about that earlier, why are their structures different. Structures are exactly the same as a class, except by default, everything is declared public. So anything that's declared, if you have an access modifier, anything that is declared between these two lines, which you can do as a member, is going to be considered private. Okay.
I have a question.
Yeah.
For a structure, can you declare public and private?
Yep. Everything's the same. You can declare something public, but it's kind of like not really useful because everything is public by default. So here's a first example of what a class looks like. Okay. So it looks kind of like a structure. If you just ignore the part down here where it says public, just look at the top, it says class rectangle. It has two members inside of it. One's a width and one's a height, right? There's two member variables here. What's the access specifier on those two? They're private by default, which means only the rectangle class can access those. Which means if you try to create a rectangle and try to use the width and height from that rectangle, when I say use the width and height here, I'm going to go back to my example here. If I make this thing a class, remember everything in a class by default is private. This is now private, which means no one can access it, which means I get a compiler error now when I try to access it like this. You guys see how that turned into a squiggly? And the reason why is because it's private. And the error specifically is that this everyone variable is inaccessible. It means that I cannot access it. How do I change this? Well, there's two ways. You can just put public, and anything below this in the class is now public. Everyone can access it. Or it can be a structure, because everything in a structure is public by default. Okay. Just want to talk about that's how that's used. Yeah.
So the bottom, after the bracket, it says rectangle.
I'm going to get to that. Yeah. This is an object type. So this is basically declaring an object. It's kind of an easy way to declare another variable. But before we get to that, there's public, and then I have two functions in here. Okay. These are also members. They're called member functions. All right? These are public, which means whoever uses a rectangle can call these functions, and that's all they can do. They can't use these variables. The only way they can use this rectangle is by calling set values or by calling area. All right? So at the bottom here, this is a new thing. This is actually has been around since the C era. you declare a class. You say these are all the things in a class. And if you just want to auto create a variable or 2 or 3 with that class type, you can create a variable and you just put the name of what the variable you want to be in between the curly brace and the semicolon. And that will basically be the same. This is exactly the same as me doing, if I did this and say, so if I did this, see how I put the name of a variable inside there? This is exactly the same as me doing that. Okay? Doing this on a separate line is just the same as me putting it inside here. And really just to save you some time. Personally, we don't allow this. We don't allow you to put variables inside here, the name, like this. What's that? Yeah, well, an Overwatch team on Team 4. Because this is kind of like a little bit like unnecessary. It's a little bit harder to read. It's also less explicit than just putting it on a separate line, too. And by putting it here, this variable now lives outside of main. I want the variable really to live inside of main. But I want you guys to know that this exists, because you might see this in some other code that you read, and you're like, what does this even mean? It just means create a variable like this. That's all that means. All right?
So it's better, you think, to not do it that way?
Yeah. I would just create, on the separate line here, I would just say rectangle rect. That would just be better. It's just the same as if I were to do rectangle rect or int a, it's the same as, it's just a variable declaration. Nothing really crazy about that. Okay, a few more things here. So how do you actually get access to these functions? So you use the dot operator between the variable name and the function you want to call. So look here, there's a variable called rect. I just put dot. And that's one of the functions I can call. Another function I can call is area.
You can also get rect.
You can get rect, yes. So going back to these functions, set values, because I'm about to give you guys a lab on this, just to clarify. There's a function called set values. It takes 2 integer arguments, and it returns void. Area takes no arguments and returns an integer. Okay? Remember, that's how functions work. And remember, if something returns a value in a function, you can use it and assign it. So this thing returns an area, it literally returns the area of a rectangle and assigns it into a variable. And remember, the only members that you can't access are width and height because they're private. Okay? So here's an example of a program that uses so it also is showing you a brand new way to use the, you guys see there's a colon. I just want to break this down, and then I'm going to give you guys a lab and then get you guys a break. So here's my class. Okay. It has 2 member variables, width and height. It has a function, set values, that takes 2 integers and returns a void. Notice there's a semicolon right here. There's another member function called area, which takes no arguments, returns an integer. However, look here. There's a curly brace there with a return statement for width and height. This is what's called an inline function declaration. You write a function, you write the prototype for it. Remember those prototypes? It means describe it, that you need the name, return value, and types. This right here is a function prototype for set values. It has no implementation. This right here, right between the curly brace, is a return statement that says return width times height. This is saying return my width times my height. If you call this function area, it's going to take these 2 values here, multiply them together, and return them as a result. It's called what's called an inline function declaration.
Is that a friend?
No, it's not a friend. It just means, all this means is you have control over where you write the guts of your function, right? Where you write the implementation. And this is showing you two ways you can do it. One, you can do it right here, inside the place where you declare the function, inside the prototype. Or you can do it like this. This is the other way you can implement it. So one is the inline. If you want to declare that function, if you want to define that function outside of the class, notice where the code bases are, outside semicolon. If you want to do this, if you want to write this function outside of the class, you have to define what the class name is you're writing the function for, put 2 colons. That's the same as this. It's the scope operator. It's the same we use for namespace for like std. And you write the function name here, and write the function implementation like you normally would a regular function. This is actually really important because we're very soon going to start using multiple files. Okay? Everything we've been doing has been in one file. You can't really make a game like Overwatch in one file. And you oftentimes have to break apart files into what's called a header file. So it's a separate file that typically is just a bunch of these class declarations, and another file that's paired with it that we usually call an implementation file that has a bunch of these in it. So you separate out the two. You typically have one thing that describes all the data variables and all the functions, and another file which describes all the functions that are inside of it. You break those apart. It's not only important for organization's sake, but it's also important for compilation. It's also important for when you have hundreds and hundreds of header files, you need a way to basically be able to say, hey, this is what I really care about. This is just describing the data. And it's really important because in the future, you're going to get into these weird things called circular dependencies. And I know you ran into them a little bit, Cody, where you had circular dependencies. You get into these things called forward declarations. We'll get into all that fun when we deal with asteroids and multiple files. But this is why this is the more common way to write a function, okay? Using a scope operator and declaring them.
How come you're able to access the width and the height while writing those functions?
Right, this one here? Why? Because they exist here, right? Like, well, how does this get access to this? Aren't these private?
Yeah.
Right? Well, look what it is. When you say rectangle colon, it's like changing a directory almost. Like you're saying, okay, well, I'm talking about a rectangle right now. Treat me as a member of rectangle. Set values lives inside rectangles already. Anything inside of here can access width and height. Okay? Anything inside of here can access width and height, which means any functions declared can access width and height too. This is a function that lives inside rectangle, right? Which means this is technically part of the rectangle, which means this entire function is allowed to access width and height too. And this width and height right here is this width and height. Like even though they're completely on separate locations, this is actually modifying the width and height that you declared up here. Okay? That's what this colon rectangle means. It means, hey, I am the set values function that belongs to a rectangle. I'm allowed to access its private variables, and I'm changing the same variables that are declared up here. Does that make sense?
So because of the colons, you're allowed to access the private.
Right. So here, remember when I said members?
Yeah.
Like members can be variables or functions. It's kind of like being a member of a club,
Okay.
right?
Yeah.
These guys belong to the rectangle club,
Okay.
right? Set values is a member of the rectangle club, right? And you know that because it says rectangle colon. You're saying this is the function for the rectangle club.
Yeah.
So I'm allowed to access the width and height, which are also other members of that same club. Okay. That's the only way that you can access those private variables.
Okay.
Is there a term for the two column?
It's called the scope operator. You guys have been using it. STD colon cout.
Yeah.
It's the same exact thing. You guys are doing it already. It just means this is what I'm in relation to. Okay. So now that set values is here, here's how we use it. I declare a variable called I get rectangle rect. I call set values, right? So I'm setting 3 and 4. 3 and 4 correspond to x and y here, right? So what is 3 here? What does 3 actually represent in a rectangle? the width, this represents the height. If you're setting the width to be 3 and the height to be 4, and look what it's doing after this, call cout rect, then calling area. So this is what outputs here. It just means call area, which calls this function up here, which then returns width times height, which is 3 times 4, that returns 12. Okay, as the area. Okay, questions? Yes.
Can I implement it so we can fully understand it?
Let's go to another example of this. So here's an example, same exact class, same exact functions, nothing's changed. The only difference is that now there's 2 rectangles here. And that's one of the most important parts of classes, is that you can declare multiple variables of that same type. So you have several objects here. You have a rectangle and a rectangle B. And we're calling set values on both, and we're calling area on both. In this case, rectangle and rectangle B are 2 completely separate objects. There are 2 separate rectangles completely. So even though I'm calling set values, the same set values function, I'm calling them on the different rectangle objects, right? This is setting the values for the first rectangle to have a width of 3 and a height of 4. I have another completely separate rectangle which has a width of 5 and a height of 6. They're 2 separate objects, which means they have their own copies of what width and height are. So that when I call area, depending on who I call it on, I get 2 different results. Does that make sense? Like why you get 2 different results here? There's actually 2 different rectangles. You can make as many rectangles as you want to, and everyone will have their own copy, right?
So can we, you said before, if we just want to declare inline, we don't have to have the rows of rectangle set values in there.
You mean if you could do this in here if you wanted to, like just like this. So you could put curly braces inside here.
So you can put all of that in. I just was wondering if you did the return, the inline declaration.
You mean take this and put it down here?
I mean, do you have to do the void rectangle set values if you do the inline declaration?
If you do this one here, you still need to have both functions here.
Well, no, just the inline declaration, just a separate.
Yeah, this one here. You're asking, do you still need this guy?
No, do you still need the other one, the void rectangle at the bottom? That one. In the middle.
Oh, this one here?
Yeah, would you still need that? Could you delete that and still get it to work?
Yes, you could delete that if you wanted to. You can write that. So if I had my right now it's like this, right? And then okay, that's what we have right now. And it also has, you declare your set values function like this. But remember, you have to put your scope for, hey, this belongs to the rectangle club. I'm implementing this guy. Okay. So this is what exists right now. And you notice there was a green squiggly up there that went away. You don't need this down here. You could do it up here if you wanted to. If you did that, you have to create variable names for this.
That would be easier to do inline.
It is for small, like one-line functions. Yeah, you can feel free to do that if they're simple like this. However, I want you guys to get in the habit of not doing this because more often than not, you're declaring them outside of the class. You're doing this. Because oftentimes your functions are more than just a couple of lines. And it's actually better in the case where you separate them, because again, you're typically going to have them in separate files. And it's going to become more clear because when you have them in separate files like this, it actually gets to be a lot easier to get your whole project to build. It's a weird problem to get into. Once you're going to hit a threshold where if you start putting all this stuff inside of the header file, it means that you're starting to introduce dependencies. Like if I had a rectangle class here, and I had a different header file which had a circle class, and I had a different one that had a triangle, and they all kind of like needed each other, If you have all of your functions declared inline like this, eventually you get into a point where you get what's called a circular dependency, where, like, let's say a rectangle needs a square and a square needs a rectangle. Like, they both need each other to build correctly.
Don't do it, man. Don't do it.
You get into, it's kind of like a catch-22 situation, and the only way to resolve that is by moving the function notation into a separate file like this, and then using what's called forward declarations to work around the problem. So I would just get into the habit of doing it this way first. Be aware that you can do it this way. There's nothing wrong with doing it this way. Sometimes it's actually more efficient as well. But just understand that you really you do both, like you mix it up a lot. Okay.
Usually make getters and setters or line like that.
Yeah, that's a very common case. When you have a function that all it does is sets one variable or gets one variable and returns it. Very common thing. Okay. Let's ask a question here. What would happen in my example if I had a rectangle like that? Okay, so this should just print out 12. Make this 12. What would happen if I called this after I called area?
Probably gonna go.
What is actually happening? What's the order here? First thing I'm going to try to do is print the area of my rectangle. When I get to this line, what is the width and height of my rectangle? It's not 0. It's actually undefined. It means that it doesn't know what that variable is. It's going to just be whatever was in that memory at the time, which could be 10 million. It could be negative 89 billion, some number here. Let's actually figure out what it is. Can you guess? That just happens to be what the memory was at that location multiplied by another thing that was just whatever happens to be at that location. So you get an undetermined result because width and height were never assigned a value, right? So there's a way to make sure this never happens. And this is a very, very important part of objects. There's a very special function called a constructor that belongs to structs and classes. A constructor is automatically called for you. It's a function that's automatically called whenever you create an object of that type. It allows you to initialize variables to something reasonable or sane. It's just, a constructor is actually exactly the same as a regular member function. It's exactly the same as one of these guys here, or like area. The only difference is there's no return type, not even a void return type, which means that doesn't even have one of these. And the name of this function has to be the same exact name as your class. If you follow those rules, like it's kind of like a set of like casting a spell or something, like you have to have a very specific set of requirements, then it will treat it as a constructor. Then C++ will call it for you automatically every time someone creates an object of that type. And there's some really kind of special rules about constructors that are kind of neat. A constructor allows you to control how people use your object. So let's talk about this a little bit. Let me give you, this is what a constructor will look like. So it looks like the same exact name as the class and no return type. Okay? That's what's, if you see that's what a constructor is. It's not calling a function though. Literally, that's the bare minimum. Notice I have curly braces with nothing inside of it. It has nothing inside of it because it has no return value. It also has no arguments to it. But why is this? Why would this be useful? Well, you can add arguments to constructors, and this is why it starts getting to be useful. Okay. So here's an example of a constructor that has 2 arguments inside of it. Can you guys spot where the constructor is here in the class? What line is constructor on?
8.
8. Remember the rules for a constructor. You're looking for a function that doesn't have a return type. So here, has no return type, and the name of the function is exactly the same as the name of the class. Okay? Once you have this, this allows you to give people using your class a way to pass values to it when you create it. This is it's kind of like this is the very first function that ever gets called on your class. This is guaranteed. If you have a constructor, it will be the very first thing. It's very important because a lot of times you want to initialize a class with some variables, or you want to make sure something is initialized before anyone uses that object. So here are two rectangles, rect and rect B. And you see here, when they're creating this rectangle, they're passing in two arguments, which match up these two arguments here. And look at this. This is how you create an implementation for a constructor. Rectangle, colon, colon, rectangle. It's a little weird, but they're actually two different rectangles. They're actually two different. This is the class. This is the function name, which happens to be the same as the class because it's a constructor. Notice to the left of it, there's no return value, because again, constructors don't have return values. And it takes two arguments, A and B, which are assigned to width and height.
So the rectangle is the class and the other one's the what?
The constructor, this is the name of the function, which happens to also be the name of the class. They're both the same. This is how you can recognize this is a constructor implementation.
Is it possible to make a constructor that doesn't have the same name
Nope.
as the class?
That wouldn't be a constructor. It has to be the same name. In fact, you can't declare a function with the same name anyway unless it's a constructor. So,
Hey Keith,
yeah.
when you make a class, if it automatically runs the constructor,
Mhm.
what value is being put into width and height when you first make the class?
It's up to you. If you don't specify value, it'll be undefined. It's a good question. Like if I just wrote this, right? I have this constructor. That's the name of the class. That's the name of the constructor. If I do nothing, I'm going to get rid of this set values function. So we don't need it. Oh, another thing too, when declaring your constructor, it's important to make sure it's public. If you don't make it public, no one will be able to use it. So what happens in this case when I print area? I didn't assign width and height. Same exact thing, it'll be undefined. It just happens to be the same number. But here's one thing you can do for a constructor. You don't have to do anything. You can just say width equals 0, height equals 0. I didn't specify width and height anywhere. There's nowhere here where I put 3 and 4, remember? But at least now, when I run this, it'll say 0 because it's been initialized. But this is not very useful. This is a very useless class because the only way width and height will always be 0. And I don't want to just put like 3 and 4 here. Why? Why don't I just want to do that? It'll always be 3 and 12, yeah. So if I had like 3 rectangles, they'll all be 12. This is also not useful. This is why it's more useful to have arguments that get passed in to your constructor. Here's an example, A and B. And when you're initializing them, you pass them in via parentheses. This is the variable type, this is a name, and here are the two values. You know that you can pass in two values into a rectangle because that's what was declared in the constructor earlier, A and B. It takes two integer values. Okay? It doesn't take two strings, doesn't take two characters, it takes two integers. Another rule is that you yourself, as a programmer, are not allowed to call a constructor. You just can't call a constructor function by yourself. A constructor is automatically called for you when you create an object, and that's it. That's the only time a constructor is ever called. Called one time, you get one shot. It calls it one time only, and they're only when the object is created. Okay? Okay. keep in mind, no return value, not even int. So it's literally just saying A and B get assigned to width and height. So 3 and 4, 5 and 6 are assigned as width and height. They don't actually return anything. The only thing they do is they take variables and they don't give back. All right? Okay, there's another way you can write constructors. You can actually write more than one constructor. All right? What does that mean to write more than one constructor? It basically means you have an option of which one is going to get called. You only ever call one constructor, but you can give people an option about which one is actually called. So here's an example where I have two constructors. Okay? This one you guys have seen. It takes two arguments, int and int. That's here. But look at this one here. It takes no arguments. I have two constructors. What this means is that there are actually two different ways I can create a rectangle now. Let me show you guys an example of what this actually means. If I go back to here, and let's say I create a constructor that takes two integer arguments. This is basically what was up there earlier, right? And I need to pass in 3 and 4, 5 and 6. What if I don't want to pass in anything here? I have a C rectangle, right? Well, it's actually giving me an error because it says you are required to tell me the width and height. You are not allowed to run your program unless you tell me what the width and height of that rectangle are. All right?
So therefore, you use two constructors so you can have one. Fair enough.
Right. If you want to support this, if you want people to be able to declare a rectangle without telling you what the width and height are, you need to have a constructor that lets you do that. So right now it's not letting me because it only makes sense to have a width and height for a rectangle. But if I create another constructor here, like this, that takes no arguments, and I implement it down here, and I'm just going to set width, I don't know, 42, those two. Now I have a constructor that takes no arguments, so when I go down here, there's no compiler error. The program will build correctly because it's found a constructor it can call. It'll automatically call the constructor whose parameters match the arguments that are passed in. So these two call this constructor because it has two arguments, and this has two variables passed in. This line we'll call this constructor because it has no arguments inside of it. So it'll print out 12, 30, and 4200. Okay.
What's the best way to organize all of that?
I'm sorry?
What's the best way to organize all of that? Say you have multiple constructors, right? And we say, for instance, rect C. I mean, how you just did that rectangle that's undefined with no argument.
Yes. This one here?
Yeah. And you had a bit of like, when you think about a large scale game, how would you best go about trying to organize your constructors so you know which ones are called?
It's up to you. This is where programming comes. Like if I were writing this rectangle class, I would ask myself a serious question like, do I want people to have a rectangle that doesn't have a width and height, that has a width and height of 0? And if you were asking me, I would actually delete this guy. I would not have this constructor. I would only have you have the one where it takes two arguments. What this means is that you cannot use a rectangle unless you specify width and height every time. This is safer because this means that if you have like a junior programmer or someone new that's using rectangles, there's no way he can get into trouble, right? He literally cannot make a rectangle without a valid width and height. He has to have typed in a number here. He has to have typed in some value here that makes sense for it to work. Otherwise, it won't even compile, which is why I would err on the side of making it as restrictive as possible. Only let people use what's actually available to them. Okay. All right. A couple things. Rectangle B, this we'll call the default constructor because it has no arguments. It's very important that you can't realize that you can't use empty parentheses to call the default constructor. It's a little weird because you use parentheses to pass in values to a constructor, but this is not the same. This right here is actually you declaring a function called rectangle C that takes no arguments and returns a rectangle. This is you declaring a variable called rectangle B of a rectangle type. Well, as soon as you put empty parentheses like this, it means you're declaring a function. This is where some of the difficulty in C++ comes from. It's a little bit ambiguous. You might read this line, skim over it, and not think twice about it. But C++ will know that this actually means it's a function. You might not have realized that when you're writing it. But there's lots of ways to screw up this thing. An ambiguous set of parentheses somewhere can cause a lot of problems. So that is not how you call an empty set.
Running the parentheses after the right C, wouldn't that make it a function?
This one? Yeah, that's what it is. This is a function. You're right. That's exactly what this is. This is a function.
Whereas the one above it's
It's just a variable, right? Yeah. You're actually get an error here. Well, you won't get an error there, which is why C++ is really weird. If I do this, right, and I don't call area, it built. I have rect_c. What does rect_c actually mean? Well, let me call area on rect_c. Let me call the area function on rect_c like this. Oh, that's weird. Why do I get an error down here?
Because there's no rec C function.
Yeah,
But there's no rect_c variable.
variable order. Yeah.
This looks like a variable. It's actually a function. What does that mean?
But there was no construction.
That's a function I can call, which means I can do this. No error here, no error here. Now I get what's called a linker error, because it's like, yo, you're calling this function. What does it do? Where are you going to write this function? Well, this is essentially you doing like Oi, governor. Oi, governor. This is you doing this. Okay.
Could be no.
This is essentially you doing something like that. Even though I'm not declaring this function here, like, because that's not allowed, but that's essentially what you're doing. You're creating a function like that. Just from a set of parentheses like that. That's all it is. It's like, oh, you must mean you want a function. That's totally what I'm going to do for you. And this is an error because I don't have a default constructor. That's what so I said default constructor. That's the name of a constructor that takes no arguments, like this. A constructor that takes no arguments, like this, is what's called a default constructor, because this is what's called when no one passes in any arguments. Something very interesting about C++, I really want you guys to know, if I don't have any constructors declared, C++ will automatically write a constructor for you. It's hidden. It'll write it during compile time so that you can do stuff like this. Look here, I don't have a default constructor up there, right? But I'm still allowed to call rect_c. That's actually okay. What happened before when I didn't have a default constructor and I tried to do that? So see here how I have a constructor? Look here when I'm trying to use rect_c without any arguments, I'm getting a compiler error, all right? What happens if I just get rid of, so this is going to be a compiler error. See how there's a compiler error right there? because I don't have a default constructor here. I have a regular constructor. C++ will automatically write you a default constructor as long as you haven't already written a constructor in your class. Isn't that crazy?
How does it look though?
So,
It looks. This is exactly what it looks like. It looks like this. That's it. That's what it writes for you.
Oh, so you can't really do anything with it.
You can't really expect it to do much. It just will write that for you, just so someone can create an object of it with no arguments.
always be on the
so it's not something that you can just like skip the step and just let it do that.
Yeah, you typically don't want to do that.
Okay.
What I just wrote up here is exactly the same as, if I delete that, it's exactly the same as what C++ will write for you. But it will not generate you that default constructor if you already wrote a constructor, all right? So if you write a constructor with 2 arguments, it's like, oh, he wants this thing to require 2 arguments, so it's not going to write it for you, all right? Does it make sense? There's like magic happening here. You guys are starting to open up the rabbit hole a little bit. It's like there's secret things. There's like hundreds of these little tiny things that happen, right?
But it's
Okay.
not really that useful.
It's only useful in the way that you can quickly write a class,
Yeah.
and you can say, well, anyone can make an object of this type without you writing that constructor. It saves you like, what, 4 lines of code?
Yeah.
But it's not really a great 4 lines of code anyway, because all those width and height in the case of a default constructor are uninitialized. Remember, if I do this without calling constructor, my width and height will be,
It's gonna be some crazy number.
yeah, it'll be some crazy number because it wrote a constructor for me. And it's like, well, that's what you want, I guess. Yeah. So if you were to write a default constructor, at the very least, you should do this. Okay? At least you initialize it, all right?
Aren't you supposed to have width 1, height 0?
With 1 height 0?
So you can multiply by 0?
No, you can multiply 0 by 0. It's fine. This will always return 0. All right, so I just want to show a bunch of different ways you can call constructors, because I showed you a way that you can't call it, which is you can't put parentheses in there because that's a function. When you put parentheses around your constructor initialization, so when you're writing, like if you go back to here, so see how rect B has parentheses here? That's what's called the functional form of initializing an object. There are lots of different ways you can initialize things. If you want to, if a constructor only has 1 argument to it, 1 argument only in the function, you can initialize like this. So if rectangle only had 1 argument in its constructor, for whatever reason, let's just say it only had A, you're allowed to create an object. Okay. Doesn't make any sense here because the rectangle's width and height. But if you have a constructor with only 1 argument, a single parameter, you can use the variable initialization syntax. All right. More recently, this is in C++ 11, maybe even C++ 9, 10. You can use what's called uniform initialization. They're starting to kind of shift towards this trend of being able to use braces instead of parentheses. It's the same exact thing as using parentheses, except it just saves you from the case of accidentally declaring it as a function. Okay? It makes it a little harder for you to screw up. So if you want to, you can use braces as well. And if you want to, you can also put an equal sign before the braces, just like this. So see here, these are 4 different ways that you can declare and call that one. See that there's 1 constructor here for a circle called double R. Okay? This one here is the way that you've seen. You can call a constructor by passing parentheses. These are all equivalent, exactly the same way. If you have 1 argument, you can use initialization. You can also replace the parentheses with curly braces. And if you're using curly braces, you can also just put an equal sign in front of it if you want to. It's personal preference as to which one you use. It's all about style and coding standard. Typically, so far, we typically do this. This is the kind of the most standard way to do it. Occasionally, you'll see this as well. Newer programming books and stuff will ask you to use it that way just because it's a little bit safer. Okay. This is why. Almost done. Actually, I'm going to skip this part for now. I'm going to have you guys do some lab after break. So why don't you guys take a break now for half an hour. I'm going to give you guys a lab, and I'm going to put the lab up on Zool, and then we'll continue the lesson plan and do the lab. Hey. Okay, all right, thanks for letting me know.
I don't know for sure.
Email me the homework if you do that, if you do end up in that situation. So.
Well, I'll let you know probably midweek. I'll email you saying I can't make it because I don't know for sure. So.
Okay, thanks for letting me know.
Until August 1st, I don't have a secure ride
Oh,
anymore.
okay. Yeah, I guess like your bike is totaled, right?
Bike's total, car just needs to be registered, and it's not street legal because small checks.
Oh, that
Got
sucks.
aftermarket in inside of it. Stock parts.
I used to have a car with aftermarket intake. I used to have an RX-7 third generation, and the thing was super loud. Was it, what generation was it? Second gen? Okay. Those are a little better. Did you have twin turbo one of those? Oh, okay. Those are actually.
Funny story. I paid $3,000 for it.
Yeah, that's about the going rate for a lot of those things. But those things are super unreliable. Like my third generation has so much work it needs to do. So in order to get
But
better.
I'm sweet August 1st, then I'll be good. Might have to get it done under the table, but still works.
Okay, cool. Hey.
Yeah, do you ever have those moments where your work makes you work late nights and the next thing you know, when you have to go somewhere early in the morning, you get extremely tired?
Yeah, I mean, you mean if you don't sleep a lot?
It's been happening. It's been happening to me recently. These last 2 weeks.
Yeah, the key is to go to bed early, leave if you work late, and try to catch up if you have to take a nap. My life is that because I have a baby, so